right. I think we should get started. The only thing I wanted to mention is that we have the next meeting scheduled for April 10. Um, and we'd love to have a volunteer speaker for that. So if you have something that you want to share that you think is useful, it's great. You can go, if you haven't been to these, previous meetings are on YouTube under the Harmonized MRI handle. And you can get an idea about the presentations and the kind of discussions that we had before. So we have I think about a dozen or so new to registrants since last time. So this meeting is it's not supposed to be a top-down like us developers kind of dictating where the field is going to go. We really want this to be useful and interactive. So should we just start maybe with Francesco's presentation, and we can go over other things in the end? Does that sound good?
Sorry, I didn't get.
Yeah. So
Should
if,
I
if
Yeah,
it's
speak?
so
okay, if it's all right with you, Francesco, you can just go ahead.
All right, with pleasure. So thank you for having me. I'm going to show you some pet project that I have been working on in the last few weeks. It was part of it was also made with some vibe coding, so I'm disclosing myself, but there is quite a lot also done handcrafted in my free time. So I will share my screen if it's all right by you, so you can have some idea. Um, and it should pop up very soon. So I think you should be able to see it.
Yes.
Um,
yes, we see it. That's
so
fine. Yeah.
perfect. So this presentation, I have to also disclose that I have prepared it for my group here, and they're not very familiar with Pulseq itself. So the couple of slides initially, I think it will be redundant for you. But I'm going to talk to you about NIM Pulseq, that is a porting of Pulseq to yet another language called NIM. I don't know if anybody is familiar. And of course, I did it not just for fun, but it's also because it enables some interesting tricks that you can do with Pulseq. And the idea is this word interactive, so bringing more interactivity to Pulseq. You know what Pulseq is and how to write it, and currently you can write it in MATLAB or in Python. And both of the languages have very similar features and syntaxes. Um, if one question that I had, so one situation that I had was first of all the need to adapt one sequence to different systems. And I know that even some commercial entities use Pulseq to distribute their sequences. And of course, if you want to have a sequence that is somehow optimized or meant for a specific system, you either need to prepare a seq file that runs more or less everywhere with a minimum common denominator for all the systems, or you need to ship multiple seq files, each one for each system. Or if you want to do some real-time optimizing adaptation, then you need to send your user the script source. In details, of course, you need to mostly change this ops structure that contains the characteristics of the system. So our current workflow, even if we only have one system, and I think this is a common workflow with many people, you run your MATLAB script or your Python script on your computer, you put the seq file on a memory stick, and then you put it on your scanner. And if you want to do any protocol optimization, which can be as simple as changing the resolution or the field of view or the TR, then you have to go back to your workstation and do this all over again. And this is, of course, much different from what you're used to in scanner product sequences, where you have at your fingertips the possibility of adapting at every protocol aspect. At least on Siemens. I honestly don't have experience on Pulseq on other systems, but I know a little bit the Siemens scanner interface. I know it allows positioning and rotation, but there are a few other adaptations possible. I know that there are some extensions that are implemented now with flexible timings, with the soft delays, but it's still quite limited. So I thought that one cool thing would be to add one possibility to our frameworks. And in addition to MATLAB and Python, now we also have NIM as a language to produce sequences. NIM, what is NIM? Who of you knows NIM? Can you do a show of hands? Maybe I can see you on my screen. Put your hand up if you know NIM. Nobody does. So the cool thing about NIM is, first of all, that it is compiled and the output is a single native binary. So it's under Windows, it's an exe file that doesn't have any library dependence. So one single exe file can contain your executable, can contain even user interface. And you don't need Qt, you don't need GTK, you don't need anything. At least under Windows, you can just execute it. And this is what made it particularly interesting. Apart from that, at the general level, NIM is mostly procedural language, not much object-oriented, although some objects are somehow supported with some syntactic sugar. It is a compiled language, and if you look into it, it will remind you of a cross between Python and C. So you have the statically typed of C, and but then you have the syntactic structure of Python and the high level language of Python. The statically typed is important for so that it could be easily compiled, and a lot of errors can be caught already at compile time. So you spend less time debugging after you have a program. But as I said, the attractive thing was the compiled part and the output as a single binary. While I was using it, I also found some cool features, but I leave it up to you to explore. So you want to know, what does it look like? So on the left, we have Python. On the right, we have Pulseq. As you can see, most things are really one-to-one ported. So you have make sync pulse that also accepts the same arguments. The difference, it's convention. Python uses underscore, NIM uses camel case, so I kept the NIM convention. But apart from that, most of the things are really a one-to-one. In NIM, we have some numeric libraries, but they add weight. So if you want to have a very lean binary, then you don't want to rely on too many external libraries. And for example, when you do arrange here, in NIM, you would do just a loop. This is not as bad as it sounds. I mean, you need to write a little bit more, but loops in NIM, since it's a compiled language and it used C as an intermediate, have really effectively no penalty. So they are as fast as using the corresponding arrange in NumPy. So don't be afraid of using loops. I know that that Python is much slower than that. So if you want to get started with NIM Pulseq, you first have to install NIM. Under Linux, you install with your package manager. Under Windows, you have a utility called choose NIM. If you just execute it, you say install the stable version of NIM. You don't really have to care about dependencies. It's super easy. It's taken care of. And then you use Nimble, which is the package manager of NIM, like pip for Python. This is for NIM. And you can install the NIM Pulseq dependency directly from the GitHub source. So once you have this, then you can import NIM Pulseq into your NIM script, and you can write the sequence as you would more or less in Python. So of course, in Pulseq, all the examples that are currently in PyPulseq are also ported to NIM, so you can just have a look what it looks like. But the interesting thing is that before actually creating the sec file, the sequence.nim is compiled to your executable. So if you program it correctly, then you can have this executable that is dependent on some command line parameters. For example, you can have a TE as a command line parameter and then have it write a sequence with a TE of 2 different parameter. You can put the scanner characteristics, and then you have one binary that you can distribute and that generates many sequences. So I'm not recommending it necessarily, but if you don't want to distribute the source code of your sequence, if you use NIM, you can just distribute the binary, but still have a generic sequence. This, however, you need to implement yourself, the command line parsing, but it is possible. I did a test, by the way, on a simple sequence generation. Once you have the exe file, or the executable file, you have sequence generation that is about 50 times faster than Python. So it's around 13 milliseconds versus 600 milliseconds for a simple sequence. So these could be also attractive if you have sequences that are quite heavy 3D sequences that need to recompile with different parameters. But as a companion to NIM, so remember one of my first motivation was to have a sequence that was adaptable to multiple scanners. But then on the other hand, I also had the problem that it was hard to know exactly the parameters of each scanner. So I also created an additional package that is called Pulseq Systems. I mentioned it in the mailing, in the GitHub discussion at some point. And this is a double package. It works for NIM and it works for Python. Unfortunately, it doesn't work for MATLAB because I don't use MATLAB anymore. But basically, this package exposes one function that is get Pulseq specs, both in NIM and in Python. So it's also installable with pip. And if you put your manufacturer and your model, like Magneton, like Siemens Healthineers and Magneton Prisma, then it returns the grad unit, the max grad and the max slew rate, and the B0 of that system. So you, if you incorporate this package, you don't need to remember all the characteristics. You can just adapt your sequence to various vendors and models. And so far we have the NIM Pulseq, that is just the porting of PyPulseq to NIM. So it doesn't do anything extra than what PyPulseq does. Actually does something less because it doesn't contain any plotting tool. So for this, you still have to rely on Python. My personal workflow is write the sequence in NIM and then read the sec file with PyPulseq and do the plotting, do the reporting from PyPulseq. And I wrote a small script, a small Python script that does just that. But what, in my opinion, is really the best feature is the NIM Pulseq GUI package. So this provides a user interface for your NIM Pulseq sequences. And again, this is completely self-contained. So it creates one single exe file that I can put on my scanner and have a user interface for the scanner. Under Linux, it requires GTK, but under Windows, it requires no dependency. So this means that we can have a proper protocol editor. What does the protocol editor look like, and what does our workflow look like now? We develop our sequence on our computer. We transfer the exe file on the scanner. And then on the scanner, we have a dummy sequence that is called an exe runner that is able to execute more or less any exe file. So we point this exe runner to our sequence. And then when we run this dummy sequence, our protocol editor appears. So you see, this is the interface that you have. It's quite simple, but it contains everything that you want. And then you can run the Pulseq sequence with the parameters that you want. If you're not happy, you rerun these, adapt the parameters, rerun the sequence, everything on the scanner without having to go back and forth. One word about the Exe Runner. It's available for Siemens, of course, as I'm a Siemens developer. If someone knows whether this can also work under Philips and GE, I know GE uses Linux. We have to see whether it works. And it's a simple dummy sequence to run any Exe file with argument. So with this, we have also now implemented a raw data extractor. We have implemented a script that automatically updates SEC files from a shared drive. So it's very versatile and you can do everything with it. And the example is you can point it to your sequence file and say, and preload our sequence file with the manufacturer, Siemens Alteneer, and the model that you have, and then it will run the sequence protocol editor. Of course, this is what you can do. I'm sure you're interested in knowing how complicated it is to generate the user interface. Well, I think it's very easy. I try to make it as easy as possible. All you need to do is you need to install Pulseq GUI the same way with Nimble, and then you import it. And then your sequence script will not just be a procedural script to write the SEC file, but it will contain 3 functions. These 3 functions need to be the default protocol that has the options as an argument and returns a protocol structure. Then you have a validate protocol that takes the scanner characteristics and a protocol and tells it whether it is executable on the scanner or not. And if you're a Siemens person, you can think of it as the prepare function. And then you need a make sequence function that really returns the whole sequence. So the sequence object that will then be written. And if you are a Siemens person, this will be the run function of your sequence. Once you define these 3 functions, at the end of the script, you just write make sequence exe with the links to the 3 functions, and you just give it a title. And this make sequence exe does all the magic by creating the interface based on the default protocol that you have given here. So the default protocol will expose all the parameters that you want to change. And then it will use the validate protocol to find which parameter range is admissible. And then, of course, when you click write, it will call make sequence to write down the sequence. The default protocol is a very simple sequence like this. So you create a new protocol, and then this new protocol is just a hash table. So it's an array if you're, a dictionary if you're a Python user. So you just create new entries. You can have description entries that actually are not parameters, but are just things that are written. You can have integer properties, float properties, bool properties, and you also can have string list properties that are multiple choice drop-down menus. So by creating this, the protocol is now passed to the interface, which will be built based on this. So you don't have to bother about creating the buttons, creating the containers, and so on. It will reflect what you write here. One caveat is that this protocol needs to be valid on every scanner. So if you want, you can make it dependent on the scanner options. The validate protocol is just a function that returns true if the protocol is valid for the given options. For example, checking if the duration of the gradients is compatible with your scanner parameters, and return true or false if not. If your sequence is simple, the validate protocol and the make sequence protocol can also basically be based on the same logic, except that if it's more complicated and it's 3D, you don't want to make the same sequence over and over again because it will take time and this will make the interface sluggish. So that's why they're separate. And finally, the make sequence is, as you know, it will accept the protocol. You need to read in the values that were put in the protocol and then return a sequence object with the definitions and everything. So this is your GRE example, whatever you're already used to. These procedures should not fail because it should have a validated protocol already. So if it fails, well, nothing happens, but it means that you have written your validate procedure wrong. And then once you compile it with NIM, Pulseq system is automatically integrated in this. So you will have a sequence exe file where you can put a manufacturer and model as input variables. You can also have a number of other parameters, so you can manually set all these parameters if you want, and then you can say which output sequence you want to write it. So in this case, I write it to the parent function, to the parent folder Pulseq, so that I have directly the sequence in the right folder. In principle, you cannot put protocol parameters here, but you can also have an input sec file. So this sequence will write a header in the output sec file that contains the protocol parameter, so you can reload the same sec file to load the existing parameter. And yeah, so this is how you run it. And this is the presentation. I have also a small demo, not on the scanner, but if you want to see it, I can run it. If you don't care about the demo, then I can also stop here. But first, I will ask if you have some questions or if you want to have something clarified.
I would vote for a demo, but I don't know what other people feel. I would love to see it. So I have no objection. So if you don't mind, maybe we can do a quick demo.
I absolutely don't mind. This is maybe let me. Am I still sharing? Yeah, maybe just let me share the other screen so it looks nicer.
Haben Sie sich, Sie hat, Anna hat doch gesagt, dass Sie nicht anfangen wollen. Wenn Sie jetzt fertig sind.
So this is the example that is shipped. You have the protocol editor here, and as you can see, it's quite basic. Also because the package, the UI package is not super advanced, but it contains already binary search, so it will tell you the actual minimum and maximum value for the parameter that you have. So if we put 20 here, we will see that the TE, for example, the maximum TE will be 15.8. So we can put 15. If we try to put 115 and we validate, it will automatically give the maximum. And then you can write the sequence, and the sequence is successfully written. And then what I use is this ppsec test that is basically just a wrapper on the classical Pulseq functions, and you see that the TE is 15.8, like we said, and the TR is 20. And we can also do plot, and hopefully this is the plot of the GRE sequence that we are all familiar. So we can change multiple things. Let's say we put the T again to somehow 10, and then we can see that we can change the field of view between 26 and 500. No. Hopefully, if we now redo the sequence test, then we should see that the things are adapted. I forgot to write it. Fine.
Okay. Aber wenn wir das merken,
Wenn Sie Patienten haben,
Ja.
ja, es ist jetzt lange.
Now they are
das ist jetzt wieder
adapted.
eine neue Studie von so.
Yeah, so this is the small demo. Imagine having this on your scanner so that once you write sequence, you can immediately run it from the Pulseq interface.
Ja, Nina aus Holland noch nicht gefragt.
Great, thanks so much. How much of this is it all open source? Like, are there? I'm not familiar with NEM. Like, is there any aspect of this, the platform itself, or how open is all of this?
Everything is open. So NIM itself is, I don't remember the license, I guess some MIT, but everything is completely free. Everything that was developed, so my packages are MIT, and Nigui, which is the UI package, is also MIT. So you can also just distribute the binary. There was a question, Maxime, for your compiled sequences, you need to sign them. Yes, we need to sign them. So we sign them with the same certificates as the Siemens sequences. So sorry, not Siemens, our IDEA sequences. Have you considered like the validate protocol hook return some info besides pass fail? I haven't considered it. Yeah, it's possible. Remember that I think maybe the make sequence would be more suitable for that because the validate protocol is called many times also for the binary search. So maybe you don't want to have a lot of verbosity there. Of course, you can have things that you can print things on the command line, but these you wouldn't see on the scanner. But for debugging, you can put print statements everywhere. I might have missed it, but the developer needs to check for forbidden frequency in API within the validate function. Yes, I would say that would be good practice. I mean, you can also, if you want to keep it lean, you can also make the actual make sequence function fail. So it will fail when you click write sequence instead of failing at when you change every aspect. But if it's not too troublesome, then you would check it in the validate. Yes. I don't work with DPI, so this is less of a concern for me.
Yeah, just a follow-up thought on that. So maybe potentially, right now the sequence generation does not take the scan orientation into account. So I guess you could potentially also get that information and ensure that the oblique slice that you're asking is still doesn't violate the gradient constraints and so forth. But I think that there might be some embellishments there depending on the workflow.
Yeah, I think I haven't thought that far ahead. I guess we would need to also to understand the interaction with the actual interpreter on the scanner, or restrict the orientation in the interpreter. Yes.
But the way I understand it is there's essentially a way to generate the seq file and then the usual user interface, scan rotation, all of that still.
Exactly. So you generate the sec file and then it's the usual Pulseq.
Very cool. Just a new question. Do you want to take that one?
You have mentioned that you check your parameter ranges to the binary search, but what about some non-contiguous parameter ranges? You can either tell the user interface to test or not to test the ranges. So if you say test, it's one parameter when you create a property. So you can say do validate or don't validate. If you say do validate, then it will be binary search for floats and integers, and full search for bool and string lists. A full search for numerical entities is not implemented, kind of by choice, not to slow things down too much. What you do is, maybe I can quickly share again. When you have a parameter like this, even if there is no binary search, you can click validate, and it will tell you whether the parameter works or not. So you have to do trial and error by yourself. I consider doing a full search, but to keep it simple, I didn't implement it. If there is the need, yeah, then also for numerical values, then it can be done.
Great. There are no more questions. Should we?
Maybe I have a question for you, because I know, John Frederick, you are a GE user, aren't you?
Yeah.
Would GE allow the running of binary files on the scanner console?
So that's a good question. So I know that so the MATLAB runtime actually is installed, so you can run compiled MATLAB, and so that's done pretty routinely. I will try to find out and have an answer for next time. Yeah, I think it's a good question. And there are
If you
other.
can run compiled MATLAB, I expect that you should be able to run these as well, because the dependencies are very, very few. Of course, it would also need to be implemented, the conversion to the GE proprietary, the TOPE, because you still use the TOPE interpreter for Pulseq, right?
That's right. Yeah. So there would be an additional sort of file conversion step that would be needed there.
Yeah.
And then
So I
also,
guess
no, go ahead.
I guess this could also be implemented in NIM and included in the sequence executable.
Yeah, it's basically one function that you have to run. That's really interesting. Yeah, so that could be done. I think could be very interesting. And just broadly, I think for more clinical, at least clinical research use and eventually clinical use, there's something like this is probably needed. So this is super interesting.
I had a question about more like how did you come up with it in a way, right? So you mentioned that you use some AI help, right? So how much do you rely on the code agents to actually generate the core code? Just not because you're lazy. I'm just wondering how good the agents are actually.
So they're pretty good. So the UI is all handwritten. The porting is almost all vibe coded. But this was a good example because I told it to port the code, and then I used the examples and the tests as an external validation. So I didn't let the agent look at part of the examples, and then I said, okay, now test if these examples run. So this was quite well. It worked quite well. I think porting in general, also if you have existing sequences, I use Claude. This should be able to port quite a few sequences directly into NIM. Pulseq systems, well, the coding is almost nothing. I used some AI research for finding online information about the various systems.
Yeah, very, very interesting. All right. So maybe we can end that part of it. And the other thing we like to do at these is just to kind of open it up for discussion. I mean, uh, there was hopefully all of you were also registered for the virtual meeting. And as you saw from my email yesterday, the poll results are all up, and I think that feedback was super useful. So we could take a moment to go over that, and I think there are some action items that we could discuss there. But I'm completely open here to if someone has bugs they want to discuss. We also started last time, I think, going over issues on the Pulseq issues forum, and we can do that as well. So do you have a preference, Maxine?
Not really, but I think going through the polls and basically discussing a little bit, what we do would be good.
Yeah, so maybe I can share my screen. And again, anyone, this is a pretty not too big a gathering, so please, chime in.
Speak up, exactly. Yeah.
Yeah. Yeah, so this is the GitHub now has links to all the slides. Thanks so much, Maxine, for doing all this. So the poll results, I think already here, I think the first item is already something that we could really turn into action here. So the question was, should we, the community, set up a repository with cross-platform? Initially, and this was in the context of MATLAB and Python, but now we have to include NIM as well, I think. Cross-platform tutorials examples, and kind of a related question, cross-platform API toolkit, API specification. There's a pretty overwhelming support for this. And I think also importantly, most of the attendees were willing to volunteer to help make that happen. So I think this is seems like a no-brainer to me. We can discuss now, or we can kind of do it by email. You can maybe email me or Maxime and say, hey, I would love to contribute. So we can talk about where to host it. We have this Harmonist MRI GitHub organization where we've started to put a lot of things in. So perhaps that could be a place for it. I have some GE specific examples, but that could all be merged in with this, and I'd rather have it that way, actually. So I'd be very happy to sort of help, with any sort of GE specific things, which is mainly assigning these TRID labels and stuff like that. But I would love for someone to else to really take the lead on this and just sort of have this be really a community effort. So yeah, that would be my pitch here is but I'd love to get some emails and maybe we can meet separately, form a little group and just to get that started. And we can start really basic, just starting with some basic sequences, and this is what the adaptations you need to make for different vendors and what does it look like in different languages, basically. Which I realize is stuff that maybe most of us here already kind of know how to do, but I think for new users it can be really intimidating and confusing, to where do you go for what toolboxes do you need and how do you put it all together. So so that would be, I think, an easy one. Maybe the bigger question is the study group, and here I think there is a lot of support overall for a study group, either a new study group or one integrated with the existing open science one. I think there's fairly broad support for staying within ISMRM. So basically what the questions here are: establish a dedicated ISMR study group for Pulseq. Most of you would like to see one. those who answered no, what would be the alternative? And then about half said to collaborate with the existing open science study group, which is, a very viable option. And then about a quarter of those said to establish a new organization outside of the ISMM. So perhaps based on this, we could start a discussion around,
Yeah, I would actually interpret that. So basically, to me, this means that about half of people who say we don't need a new group said that we can collaborate within with the existing group. So that's actually about 12 to 13% of people who responded to the first poll, right? So to me, it actually means that there's relatively little support from the community to the idea of collaborating with the open research, open science group.
I agree.
Right. So that basically means that at least it looks like many people are actually supporting the idea of having our own study group. The danger, the downside of that is that there will be yet another study group to attend to. Also, the full members will have to pay for it. The student members, of course, don't care. On the other hand, we'll have our room at the SMRM to meet maybe and discuss something, or so maybe probably also be easier to hold in-person events within the SMRM. Yeah, so basically there's some advantages in having this structure within the SMRM, but there's also some burden associated to that, mostly to the full members, right? So again, I know realistically, with more study groups appearing, I had to quit some other study groups. So, I mean, I used to be in the engineering study group. I had to step out because otherwise it would be too many. So, I don't know how to handle that, but like to me, it sounded like I can never attend their meetings anyway. So basically, I had to step down from that, and that's a bit of a problem, right? So on one hand, we certainly have a kind of a focused crowd, and the registration for the meeting for the webinar last week shows that we generate actually quite a lot of interest. So there's a certainly good reason to have a group like that. And I feel that this crowd is quite distinctly different from the generic open science people. So
Is that true though? I feel like open science is like BART plus Pulseq, or is there anything else? I mean, I'm simplifying things, but yeah.
Well, so I think if we rename it into Bars and Pulseq, will probably be more
You
clear
get
what
killed.
we mean.
But
Well, yeah. So a bit of a question is, to me, should we become active already right now and apply within the SMRM because I think the study group committee is happening during the SMRM, or we can wait for the meeting of the open science group and basically before we destroy them, we can talk to them. Because I think we'll be in the direct competition. So if you say we organize a parallel structure, we'll take a half of the participants out more or less.
Maybe I can quickly intervene.
Oh yeah,
because
that's great that we have you, Francesco, today also as a speaker, right? So because you're one of the active.
Yeah, I am. I haven't been in the leadership for a couple of years, but I still have a lot of contacts. Actually, we have worked a lot when I was there and when I was present to not only be Pulseq and BART, so also move away from just open source, open science, but also focus on the reproducibility aspect and statistics and publication bias and so on. So it is a little bit different, the focus, than just open source sequence development. But in general, it is still a big important role. Everything that is in the open source movement in MRI is pretty much on scope. It depends, of course, on the current leadership, what they want to do. But I think if you went to them, there will be the big support for giving you space or us space.
Yeah, thanks. So I think it's a good point. Like my impression was that there is an overlap, but there also quite some difference. In addition to the point that Pulseq is not BART, right? So even that would be reason enough to see and to check whether we feel ourselves different. But again, we will be in some kind of competition to the open science group. So and I don't know. I have somewhat mixed opinion about that. So, but I've received private communication kind of contacts suggesting that it's a very good idea to do a group, an own group, because it will be nicely focused, and that's what ISMRM actually likes a lot. So, to have a group of really coherent people who are interested in one topic and focused on that. So it could be a thing to consider seriously. I don't know.
Maybe technically you also need a minimum number of full members participating in the group. It is a little bit of a burden to set up a group and to maintain it but yeah, I can help. I have quite some experience as well.
Okay, so I mean, should we do a little poll amongst the participants here to basically get another impression? Because I guess and people on this call, they're really the ones who are often around. John, can you do a quick poll or you don't have this opinion?
Let's see. I'll work on it here.
Okay. In the meantime, I've seen there was some kind of technical question. So, Matthias Aliva said they have a question. So maybe we can discuss that. Yeah. Hey.
Hi. I want to ask you about a issue that I have in the Pulseq sequence. I'm trying to run on a Siemens Freemax 0.55 Tesla, and I'm trying to do my fMRI study there, and I need to implement the EPI sequence in this scanner, but I try to acquire more than 40 repetitions, and the scanners that doesn't allow me to acquire more than 40 repetitions. And I mean, it's because the scanner thinks that I acquire one image, but it's a series of images. I can write it down in the chat. Maybe it's better because
Okay.
my English is not good.
That's okay. That's okay. I think I would recommend you to use the runs feature of the scanner of the interpreter, because the interpreter is able to rerun your sequence many times, and that will make your sequence much smaller. Another thing, yeah, so that's basically the most important part. Maybe also it makes sense for you to switch off the lip balance on the sequence special card, because that's also sometimes limits the sequence runs. So switch off the lip balance and use the runs feature. There was a kind of a bug, a limitation in the old interpreter. If you are trying to do like EPI with the image reconstruction directly on the scanner, it would limit your number of runs to 512, but that was an artifact. That wasn't a true limitation. there was a hard limit on some of the parameters, which is now removed in the new interpreter. So basically change to the new interpreter, use runs, and disable lib balance. I think that should allow you to move on.
May I ask you to write it down in the chat because some words I cannot exactly understand, please.
Okay, sure.
I tried using labels on my sequence to identify every line, but it freezes on the user interface and the scanner, so it won't run.
Okay.
Mhm.
This is strange.
Mhm. So that was my main question. So how do I properly add the labels so Pulseq on the scanner recognizes it as a long time series and runs the full repetitions without the blocking execution?
Yes. So for there is an API sequence with labels. This should run out of the box with multiple repetitions.
Okay.
I can look it up and tell. So I think it's called API RS label or something like that.
Mm-hmm. And also there's the treat label, and it was made for repetition the same block over and over, but I'm not sure if it is suitable for this issue.
Yeah, so have a look at the demo sequence. So in MATLAB there is this right API RS label. I'll paste you the link.
Okay, thank you.
It should be, you should be able to run it more or less directly. If you use Pulseq, just try to see that you can copy the logic. By the way, also MATLAB allows people to run online MATLAB and PyPulse and MATLAB Pulseq works in the online MATLAB, and as a free account, you get 8 hours of computation time, so that's enough to generate a couple of sequences.
Okay, thank you very much.
All right, let's launch the poll here. So I gave it a third option just to perhaps we can give it some more time.
Good.
Give it a few more seconds.
Okay, do we have
So,
more questions maybe, or some other discussion points?
Yeah, so we only have a couple of minutes left, but any other issues that?
Yeah, I think maybe people just, if you haven't seen it, it's also interesting to see the poll results in general. I found it interesting to see. I know it was the meeting last week was very strongly dominated by Siemens users, but what was interesting that there are more people using Brooker than Philips, for instance. So apparently, Brooker, I imagine there will be quite a lot of people who would be interested to see a working Brooker interpreter. And I know that there's a small group of volunteers working on the interpreter. Well, we're also going to test it again in the next weeks and months. We'll see how quickly that goes. But yeah, I think it's quite inspiring to look at the. Okay, it's interesting. So even on this call, we have a clear majority. The qualified majority is called, right? The two-thirds of people would support an own study group. I think with the own study group is also a good idea. If we manage to get some attract some sponsors, we may have some snacks in the study group meeting, which is good, which will also attract more people to come.
Great.
Okay.
Yeah.
Yeah, so we'll think about
Yeah.
it. We'll check it. Francesco, maybe we can also chat some other day in the smaller round. That's good. Okay, so I would say unless then any more questions, I think this meeting is set for 1 hour. So
Yep. And just a reminder about the first poll question. So anyone who would like to contribute and discuss setting up a repo, give us an email. Perhaps we can meet separately about that.
and we need a volunteer for the April meeting,
It's April
right?
10th.
So please respond within a week, otherwise we will have to ask some people more directly.
Or you'll have to listen to us for now. You don't want that.
Yeah. So if you don't want to listen to us once again, please volunteer.
Thanks so much. Thanks a lot, Francisco. Appreciate it.
Thanks, Francesco.
Thank
Bye,
you.
Bye,
guys.
everyone.
Bye-bye.